Anyone have
Yes,
an
sir.
answer? See, when
Yes,
we
sir.
are, yes, okay, tell me one by one. Okay, suppose which one is telling? Just you tell.
Sir.
Yeah,
Yes, sir.
yes.
Sir, because to correct the error in the answer, because when we add or subtract some number in BCD or XS3, then we don't get the accurate answer. We get an excess of 3 or deficient of 3. So to correct that error, we add the binary code or BCD code of 3, that is 0011.
Okay, good. Yeah, okay, it is okay. But yes, your answer is correct. But all of you getting or see, when we are talking about the access tree, if there is a no carry out from the addition of any of the 4-bit groups, okay, that time what happen? We subtract 0011. That means 0011 from the sum term of those groups. Are you getting my point? Because when 2 decimal digits are added, because what happen? There is no carry. Okay, when 2 decimal digits are added in access tree and there is no carry, okay, then the result is access x6. I am not talking about the SX3, I am talking about the XX6 if there is no carry is generated. See why XX6? So what happens, see here, the XX3, what is the actual form? When we are converting any particular binary number to the XX3, that time what happen? We are adding 3. That means what? 0011. And if there is no carry, that time what happen? Repeatedly what happen? Again 3 extra 3 are added. Because there is no carry, and originally what happened, original binary number we are converting to the plus 3. Okay, so what happened if we are not subtracting 0011, that time what happened, that particular SX3 form as a XX6. That means what? 3 plus 3, 6. So to balancing that particular, to correct that particular formulation, we are again we are getting the if we are not doing the minus 0011, that time what happened, that particular number convert to the XX6. Okay, so to maintain the original XX3 numbers, what happened, we are subtracting 011. And same thing when we are adding, when we are there is a carry. Okay, if there is a carry out, that time what happened, when there is a carry, the invalid states are skipped. Okay, so invalid, when the invalid state are skipped, that time what happen? We are add to get our original state. We add extra 011. Okay, for that particular reason, when there is a no carry, that time what happen? We can subtract 0011, and when there is a carry, we can add 0011. Okay, Anjali Chaudhary, you are getting?
Yes, sir.
Okay. And same thing, what happened? Same thing we are using in BCD also. BCD means what? You know what is the range of the BCD? BCD range is 0 to 9. BCD range is not 0 to 15 or after 9, that time what happened? After 9, whatever the numbers are generated, suppose 10, 11, I'm talking about the decimal numbers. Obviously, you can convert to the binary numbers. 10, 11, 12, 13, 14. So how many numbers are there from 10 to 15? 6 numbers are there. Okay, so we can back to our original number. That means original number is starting from 000. So if we are considering the 4-digit, because you know BCD only from the 4-digit binary sequence. Okay, that means 4-bit groups. Okay, so what mean? That means every sequence we are derived by the 4 bits. Okay, so when we are getting the illegal numbers, that means 10 to 15, how many numbers, what is the cardinality, how many numbers are generated? 6 illegal numbers are generated. And when we are defining the 6 in binary sequence, that time what happened, we are getting 0110. 0110 means what? When we are converting to the decimal number, it is 6. And why we are considering 0110? You know, in BCD always illegal numbers are 6. Okay, so if we are skipping that particular 6 stage, that time what happen? Obviously we are going to our original state. Original state is starting from 0000 up to 1001. 1001 means what? It is 9. Are you getting my point? Because we cannot go 16, 17, because 16 not described by the 4 bits. It is required more number of bits are required. 5 number of bits are required. And the what is the rule of BCD? That means only 4-bit groups are possible at a time. All of you clear?
Yes, sir.
Clear that one? Baki sabko any doubt? Any doubt?
No, sir.
No, sir.
Okay. Then we are directly going to the presentation slide. Today is okay. Today, this is the lecture number 09, and this time what happened? Another binary code that is called a error detection and correction code. Okay, today we are going to discuss some type of binary codes. This is also belongs to the binary codes, and name is error detection and correction codes. Okay, so this particular code also we are detecting the errors, and also we are correcting the errors. Okay, so what happened? Why this type of codes are required? Okay, the main objective this particular lecture today is that this particular slide we are discussing the one particular binary codes whose name is error detection and correction code, and what is the importance of this particular detection and correction code, and how we are designing this particular code. Okay, the screen is visible, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
So at first, because see here, we cannot directly go into the correction code. Okay, before correcting, we know the where is the fault. That means where is the error. Okay, for that particular purpose, we have to know what is error detection. Because at first, what is the first step? First step is that we are detecting the error. When we know the error, that time what we can find out which particular location that particular error occurs. Okay, after that what we can correcting that particular codes. So when we are talking about the error detection and correction code, always you know the detection at first, after that correction is coming. Okay, so the second slide, we are discussing what is error detecting code. Okay, then what is the main objective of this? Why error detecting code is required? See the first point. When a binary data is transmitted and proceed, okay, it is susceptible to noise that can alter or distort its content. Full stop. More precisely, the ones. Okay, this one is called the ones may get changed to zeros, and vice versa, zeros to change ones. See here, what is the meaning of this particular first point? Okay, so what when you can consider any particular device, that means transmission device. Okay, suppose what when we are one particular device, we are supplying the one particular information. Okay, and that particular device accept that particular information, and directly whatever the information you pass to the device, that particular device cannot directly or unable to directly convert to the or transfer to the other device. Okay, so what happened? Just a minute. Someone is want to join. So what happened? Again, what happened? That particular device convert that particular information to the binary sequence. Are you getting my point? Binary sequence means what? Some combination of 0 and 1s. And it is transferred to the some other device. When transferring one device to the other device, that time what happened? Unfortunately, some particular noise are created. Now what happened? What is actually noise? I have already discussed in the first class, noise means what? Unwanted signal. Some particular signal, what happened? It is not required for us. Okay, but what happened during the transmission time, that particular noise is created and disturbance some type of contents, that particular content of that particular information. Okay, due to that particular noise, sometimes what happen? Ones may get to sense to zeros and zeros to ones. And when that particular device, some particular device is there, one particular, suppose what happen? Some particular device and they are connected with each other, suppose. Okay, so when that particular device receive that particular information, that means what? Wrongly receive that particular information. Okay, so due to some particular errors or due to some particular, there are different type of noise are occurred. Okay, so that is the network part. We are not going that particular part. Okay, because this particular subject permits of only this particular electronics circuit. Okay, so just you can think that due to some particular noise, what happened that the receiver device getting the wrong information. Okay, so what happened? How we know that particular information is wrong, and where exactly that particular, which particular bits or which particular bits actually wrong when during the transmission time. Okay, so for see here, second point, for this purpose, what happened? We add extra bits of the data bits. Data bits means what? I'll discuss some particular informations are there, and what happened? This particular up to this particular part, it is called a message bit or data bit or information bit. Okay, and what happened? After that, what happened? We are using some other type of bits. That means same bit. Suppose combination of 0 and 1. We are using some particular extra bits. Okay, and information bit plus extra bit, it is called a code words. Okay, what is the use of this particular extra bits? Okay, extra bits means what? It is handle or it is manage this particular main information bit or message bit. Okay, it is correctly convert to the or correctly received by the transmission device or not. Okay, so how we can, that means what is our original message, and if something is wrong, that all the parts are handled by the extra bits. And extra bits is nothing but it is called some particular detecting code. Okay, so what happened here? The third point, code words are divided into two categories. One is called a valid code words, that means there is no error, and another one is called a invalid code words. That means what? Due to some particular noise, that particular code words has to be changed. It is occurred. It is 0 to 1 or 1 to 0. Okay. So a bit error changes a valid code word to an invalid code word. Then how error is occurred? How we can know? When the valid code words, it is transferred to the invalid code word due to some particular noise or some particular reason, what happened? This particular code word convert to the invalid code word. When any valid code words convert to the invalid code words, that time what happened? Some particular errors are occurred. Okay, see, this one is the fourth point. Fifth point is, see here, the number of bit position is differ. Okay, fourth point, last point is something different. So remember always one thing. So when we are writing some particular code word, that time what happened? This particular last statement or last point, you have to know. Okay, so what is the last point? The number of bit position, maybe 1 bit position or maybe 2 bit position, maybe more than 2 bit position, is differ between the code words, indicating the distance between the two code words. What is the meaning? Suppose what happened? I am considering two type of code word. Suppose first one is 0, 1, 1, suppose 0 and 1. This is the first code word. And second code word is suppose 0, 0, suppose 1, here 1, and this one is 0. Okay, see here, the first bit position is similar. The second bit position is, see here, the first code word is 1 and second code word is 0. That means what? It is the one difference is occurred. Third one, here also first code word, third bit of the first code word also 1, and third bit position of the second code word also 1. That means there is no difference. But fourth position is also, this one is 0 and this one is 1. And third one is also 1, 0. That means what is, this one is different, this one is different. So the difference between this particular code word is what? 3. Difference of this particular code word is what? 3. Are you getting my point? Here, because see here, here it is 0, 0, it is same, but here it is different, here it is same, here it is different, here it is. So what happened? We are getting the 3. That means the distance between this particular code word is 3. And this one is required when we are considering the error detecting code. So if someone is asking that this one is the binary sequence and this one is the binary sequence, what is the distance between these two binary sequence? Then you can consider, you can compute this way. Okay, are you getting? Are you getting or not?
Yes, sir.
Yes, sir. Yes, sir.
Okay, if any doubt, then please stop me and ask me. Are you getting my point? So this is the
Sir, why?
Yes, please. Yes, I am not here. What you are asking?
Sir, why the difference is 3?
That is why I am telling. Now, see here, this is the first code word. Suppose what happened? This one is code word 1. Okay, this one is code word. Suppose this one is the code word is 1. So okay, just consider, I am consider this one. This one is the code word 1. Okay, and this is the second code word. If someone is asking you what is the difference between the code words, these two code these two code words, which one was? This one is 1. This one is the first code word. This one is the second code word. So see here, the first bit position here also 0. The first bit also 0. If we are going from MSB to LSB, this one is also 0 and this one is also 0. That means there is no difference. Second one is 1, but second code word is 0. That means what? There is one difference we are getting. The third difference, what? Third bit is, see here, if we are going MSB to LSB, this one is 1 and this one is 1. That means what? There is no difference. But see here in 1, 2, 3, 4, 4 bit position, the first code word is 0, but second code word is 1. So that means what? Here 1 plus 1. How many? 2. And if we are going the fifth bit position, here it is 1 and here it is 0. That means what? Earlier 1 plus 1 we are getting 2 and 2 plus 1 is 3. So here we are getting 3. Are you getting my point?
Yes, sir.
So now next, suppose see here, we are till now we are discussing about the error detecting code. Suppose see here the first statement. Suppose we consider two sets. Okay, and suppose first one is denoting as a, this is the denoting the notation we are using for first set is SI, and second for particular second set we are using the notation as Z. Okay, and what represent data SI representing as a as valid code word, and SJ is representing as an invalid code word. Okay, so what happened? When we can check whether a given code word is valid or invalid. How we can check? See here, we can check whether a given code word is valid or invalid. How we can check? Okay, so this particular valid we can check the valid and invalid code word. That means we have some particular techniques we are using for checking the checking technique we are using. Okay. See here the third point, this one, for detecting single bit error. Okay, the distance between any pair of valid code words must be at least 2. Now 2 is what? 2 is whatever we are discussing the last slide, that means distance between the two code words, at least 2 is must be present. If we are getting the two code words difference is 1, that time what happen? We cannot able to detect the single bit error. This is very, very important point. Therefore, if based on this particular concept, we can generalize this one. Therefore, for detecting k errors, the distance must be k plus 1. Okay, so what happened based on this particular concept, we can generalize that. Generalized statement is that for detecting k errors, the distance must be at least k plus 1. Now, what is this one? See here, we are considering, just a minute. See here, we are considering two code words, C, W, 1, and suppose C, W, 2. Okay, there are two code words, and suppose what happened? This one is denoting as a, suppose we are denoting as a SI. We are denoting as a SI. And this one is SI means what? This one is the valid code word. Valid code word. And another one, suppose what happened? Another one, this one is called a, suppose invalid code word. Invalid, this one is invalid. Okay, now see here, suppose here also this one is CW1, and suppose we are assuming that this one is also CW2. Okay, we are also assuming that this one is CW2. Or you can consider this one is maybe some particular other code words. Okay. Now see here, if C1, if we are describing this particular CW1, suppose CW1 we are defining as a this particular code word. This suppose 1, 0, 1, and 0. And CW2, suppose C2, we are defining as a, suppose 1, 0, 0, and 0. Now see here, when we are going to this particular code word 1010, that means code number 1. Code word is 1, and there we are using two code word. We are using two code word, and second code word is 100. See here, only there are single bit error. Only this particular bits are different. Other bits are same. 1 is same, 0 is same. The third position of 1 is convert to the 0. See here, already we know in SI set, SI means what? This is the valid code word. So SI already C1 and CW2 is present. Okay, so what happened? When CW also belongs to SI set and CW1 also belongs to the SI set. But what happened here? Here see here code word 1, 1011, third bit is changed in code word 2. Code word 2 also, what happened? The third bits are changed. But what happened? These particular two sequences are already present in SI. Due to this, what happened? If only one bit is error are occurred, that time what happened? We cannot detect this particular state is invalid state. This particular state is invalid state. Are you getting my point? So what happened? Only one bit error is there. That time what happened? Due to C1, CW1 also present in SI, CW2 also present is SI. But what happened? This particular, if we are changing this particular third bit, that time what happened? Whatever the code is generated in code word 2, 100. But what when unfortunately 100 also present in SI. But already we are assuming that SI is a valid state or valid code word. Okay, for a particular purpose, the third statement is very meaningful. So what when the distance between any pair of valid code word must be at least 2. So here what when only difference is only 1. Because what when third bit of code word 1 is 1 and third bit of code word is 2 is 0. Only one bit is changing. But though it is one bit is changing, but CW1 and CW2 also present in SI. So meaning is that only when the only 2 bits are changes, that time it is possible to detect the single bit error. So what happens if only one bit is occurred? Single bit error means what? This type of fault. Only one bit is changes. That time what happens? At least 2 is required. Code word must be difference must be 2. Okay. Then if it is 2, that time what happens? Suppose 5 bits are error. So here k equal to what? K equal to 5. So if 5 bits are error, that time what happens? How many distance is required? 5 plus 1. 5 plus 1 means what? K plus 1. 5 plus 1 is equal to 6. Suppose 7 bit code plus 7 errors are occurred, that time what happen? 7 plus 1 equal to 8. 8 distance must be required to detect the 7 errors. Are you getting or not? Why you keep silence? Ready?
Getting, sir.
Well,
Waiting, sir.
okay, I am going and going. I am taking the class. It is no problem. If you are getting is very I am successful. That means my objective is fulfilled. But if you are not getting it and if you are keeping silence, that time what happen? How I am actually I measure you, because physically we are not actually meet together. Okay, physically we are not face to face. So I am assuming that you are getting. Okay, but very soon I understand that how much you are. That means you are getting or not, because 23rd is coming. 23rd I will conduct the first internal exam. That time I am getting how many students are very serious and how many students are conceptually cleared. Okay, that particular parts I will know on 23rd. Okay, no problem. Now what happened? The first point, second point, third point already we are discussing. Now third point also very much important. What is the third point? A bit error changes a valid code word. No, this one is not. Okay, this one is correct. So what happened? For single error correction, the distance must be at least 3. So what happened? See here, we are talking about the detecting. How many distance is required for detecting the code? If there is only one bit error, at least we require 2 distances required. Okay. Based on that, if k errors are there, that time what happened? At least k plus 1 is required. But this is the detecting code. But when we are going to error correction, see this one single error correction, that time what happened? Must be at least 3. Now why it is must be at least 3? See here, suppose what happened? This is the code word and this is the code word. Okay. Suppose what happened? There are some particular defined states are coming. Defined, that means defined codes and defined bit sequence are generated. Suppose this particular code word, this particular bit sequence, this particular code word, this particular bit sequence, this particular code word, this particular bit sequence. And sometimes what happened? This particular second code word also generated some particular bit sequence. Okay, different type of bit sequence are generated. Suppose what happened? Suppose this one is this one, maybe connected this one is this one, and this one is this. Don't consider last one. Last one it is not required. Suppose see here, this particular 2 code word, the same bits are there. Okay, this one. This particular code word also connecting the same code bit sequence bit, and this particular also connected the same bit. This one. Okay, this one. So that time what happened? Suppose what happened? Here distance is 1. Okay. If here also distance is 1, that time what happened? 1 plus 1 distance is what? 2. But what happened? Due to, if it is 1, that time what happened? This particular 2 states may be in the code word, same code word. Okay. So at least what happened when we are converting to this particular code word to this particular binary sequence, that time what happened? It is not a 1, it is must be a 2. Otherwise what happened? We cannot distinguish, we cannot identify the location. Actually, this particular state, this particular bit, it is coming from this particular code word or this particular code word. Because instead of 2, if it is 1, that time what happened? We cannot recognize this particular bit is coming from which particular code word. So at least 2 difference is required. Okay, so already what happened for detecting it is already 2 for single bit. So 2 plus 1, that means obviously that particular bit already connected with the other code word, maybe 2 code word, this one and this one. So for this one, suppose it is 1, and for this one, if it is also 1, that time what happened? Only you can detect the error, but we cannot correcting the error. So at least so for what happened? Either this one is 2 or either this one is 2, and anyone may be 1. So for that particular reason, what happened? For single error correction, the distance must be at least 3. Okay. Last point. Yes.
सर CW1 and CW2 SI जो वो तो वैलिड है.
हाँ.
हाँ, और इधर बोला कि डिस्टेंस 1 हुआ है जो आपने दिखाया.
हाँ हाँ.
सर अगर उधर डिस्टेंस 2 हो जाए तो उसका मतलब क्या, मतलब डिफरेंस 2 हो जाए तो एरर 3 और वो क्या इनवैलिड हो जाएगा, वही तो कहना चाहते हैं ना.
हाँ हाँ, नहीं मैं क्या बोलना चाहता हूँ, सी हियर द फर्स्ट, सपोज मैं यहाँ पे समझा रहा हूँ, मेरा पॉइंटर यहाँ पे है. ठीक है, तो फर्स्ट कोड वर्ड क्या है मेरा?
1010.
ओके. सेकंड कोड वर्ड क्या है?
1000.
ओके. तो देखिए फर्स्ट जो बिट पोजीशन है उसमें इफ वी आर गोइंग फ्रॉम एमएसबी टू एलएसबी, ओके, सो फर्स्ट एमएसबी क्या है? दोनों में सेम है, 1 1 है. सेकंड में क्या है? 0 0 है. और थर्ड में क्या है? 1 0 है. तो मतलब फर्स्ट को हाँ
एक डिफरेंस आया.
हाँ, एक डिफरेंस है. मतलब क्या है? सपोज दिस इज द एरर.
हाँ
हाँ, बिकॉज़ डिफरेंस इज 1. ओके. नाउ व्हाट हैपन? सपोज वी आर एज्यूमिंग दैट SI, सपोज ऐसा भी सिचुएशन, इसीलिए मैं एज्यूम कर रहा हूँ, इसीलिए एक में SI लिया. SI एक सेट है, ठीक है. तो इसमें क्या है? इसमें SI मैंने क्या बोला हूँ? SI इज ए वैलिड कोड वर्ड. सपोज वी आर एज्यूमिंग दैट SI इज ए वैलिड कोड वर्ड, ठीक है. तो क्या होगा? ये जो 1010 है ऑलरेडी ये वैलिड कोड में भी प्रेजेंट है और 100 ऑलरेडी वैलिड कोड में प्रेजेंट है, दोनों वैलिड कोड वर्ड में है. सो यहाँ पे मैं क्या लिखा? CW1 एंड CW2 दोनों लिखा ना मैंने, ठीक है. लेकिन जब हम लोग कंपेयर करेंगे CW1 और CW2 को, तो डिस्टेंस कितना आ रहा है? 1 आ रहा है.
1 आ रहा है, तो उसको वैलिड ही पकड़ा जाएगा.
हाँ, वो हाँ वैलिड पकड़, हाँ ये वैलिड है. लेकिन क्या होगा? ये तो लेकिन बिट तुम्हारा चेंज हो गया ना, 1 to 0 हो गया ना.
हाँ,
इस कोड वर्ड के लिए सपोज ऐसा हो गया, मैंने क्या किया? ये इंफॉर्मेशन को क्या किया? एक डिवाइस से दूसरा डिवाइस को भेजा. जब भेजने के टाइम में क्या हो गया? मेरे पास एक नॉइज क्लियर हो गया, कुछ नॉइजी से वो ट्रांसमिशन में कुछ नॉइजी आ गया. तो मेरा क्या होगा? 1 क्या होगा? ये 0 में चेंज हो गया. जब भी कोई भी इंफॉर्मेशन हम लोग डिजिटल सर्किट में भेजते हैं, डिवाइस में भेजते हैं, सिस्टम में भेजते हैं, तो उसका क्या होता है? सिर्फ डिवाइस सिर्फ दो ही चीज को जानता है, 1 and 0, ठीक है. तो 1 0 होगा, नहीं तो 0 1 होगा, और तो कोई ऑल्टरनेटिव नहीं है क्या?
हाँ ना.
तो ये जब 1 और 0 में, 1 अगर 0 में चेंज हो गया तो वो मतलब इनवैलिड हो गया. लेकिन क्या हो रहा है? अनफॉर्चुनेटली क्या है? ये इनवैलिड कोड और वैलिड कोड वर्ड दोनों में SI में ही प्रेजेंट है. तो वो इनवैलिड, उसको कैसे इनवैलिड बोलेंगे? इनवैलिड तो नहीं बोल पाएंगे, ठीक है. वो वैलिड ही है. तो इसीलिए इसमें मैंने क्या बोला हूँ, इसको एटलीस्ट 2 होना पड़ेगा, एटलीस्ट 2. वो 1 बिट से नहीं होगा, डिफरेंस हमेशा 2 होना पड़ेगा. मतलब 2 बिट तुम्हारा एटलीस्ट चेंज होना पड़ेगा. एक बिट से क्या हो रहा है? वो दोनों वैलिड ही पकड़ रहा है.
हाँ, मतलब अगर हम 1,000 का लास्ट जीरो अगर 1 करते तो वो दो
कोई भी
डिवाइड हो
नहीं,
जाएगा।
पोजीशन इज डज नॉट एनी मीनिंग। ओके, मतलब
हाँ।
डिफरेंस क्या होना पड़ेगा, 1 से ज्यादा होना पड़ेगा, मतलब 2 होना पड़ेगा, मतलब
एटलीस्ट
मिनिमम
होना पड़ेगा।
minimum. If we are going for single bit error, minimum code error difference is 2, minimum 2, maximum कुछ भी हो सकता है। If we have a minimum 2 difference, that time what happen, we successfully detect, not a correction, we successfully detect the single bit error. And what is the logic and what is the reason behind that? Whatever I am discussing this one.
Yes.
Okay, now what happen, you can this particular concept you can extend to the for error correction. अगर मेरा डिटेक्टिंग के लिए क्या हो रहा है, और ऑब्वियसली इफ वी आर यूजिंग ओनली वन सिंगल बिट एरर, एक्सक्यूज मी जस्ट मिनट, हेलो हेलो, हाँ सर मेरा क्लास चल रहा है। See here, so what happened, just you can extend for error correction. So obviously you know for single bit we have required at least two differences required. For k errors, the distance must be at least k plus 1. Okay. Now what happened, when we are talking about the single error correction, that time what happened, 2 is already there for detecting the error, 2 is required, because what happened, without detecting you cannot correct. So 2 is already there. Just you can add 1. 1 bit error, also 1 bit difference is required. So what happened, total 2 plus 1 is what? 3. For single error correction, the distance must be what? Distance must be 3.
मतलब तब SI इनवैलिड हो जाएगा अगर दो एरर आया और
और 3 एरर आएगा तब क्या होगा, हम लोग एग्जैक्ट लोकेशन को पता करेंगे और उसको करेक्ट कर देंगे, जहां पे गलती है उसको करेक्ट कर देंगे, दैट इज कॉल्ड एरर करेक्शन। तो उसके लिए 2 से तो नहीं होगा, बिकॉज 2 इज ओनली डिटेक्ट द एरर, नॉट ए करेक्ट एरर।
K+1 करना पड़ेगा।
K+1 for detecting the error. तो उसका मैं जनरलाइज फॉर्मूला तुमको दे रहा हूँ, जस्ट वेट फॉर फ्यू मिनट्स। लास्ट पॉइंट देख लीजिए, फॉर एरर डिटेक्शन वी यूज व्हाट, for how we are detecting the errors, the concept parity code we are using. One particular well-known code is called a parity code, and parity code generally we are using for error detecting and correcting. Okay, now आपने जो पूछा ये 3, that means what? See here, just a minute. See here, ये मैं दिखा रहा हूँ, देखिए ये बाद में मैं करूंगा, ये थर्ड पॉइंट में जाइए। When we are discussing this one, this one, for single error correction, the distance must be at least what? At least 3. Now, how you can generalize this one? Generalize, we can use this particular time. Third point, this one. A code with minimum distance 2 plus k plus 1. Suppose if we are using 2k, okay, the 2k plus 1, that time what happen? If there are single bit, that time what happen? K equal to 1. Suppose we are considering that here k equal to 1, only 1 bit is error. Okay, then how many? 2 into 1 plus 1, how much? It is 3. Are you getting my point? It's
Yes,
3. So what happen? If k errors are there, that time what happen? How many distance is required to correct the error, not detecting the error? So for detecting the error, it is required k plus 1, and when correcting the error, it is required 2k plus 1. That is the logic. But remember, this one is very conceptual. Okay, if you are not getting, then the next class, when we are going for further part, that time what happen, you will get confused. Okay, so this particular concept must be clear. Why k plus 1? Why 2k plus 1? Okay, suppose what happened, earlier we are saying that only for, if there is only single bit error correction is required, that time what happened, 3 bits are required. Okay, so what happened, if you are considering only one error, that time we are assuming that k equal to 1, and 2k plus 1 means what? 2 into 1 plus 1 is 3. So this 2k plus 1 means what? It is the generalized form. If k errors are there, then how many distance is required to correct that particular error? 2k plus 1. And when we are detecting k errors, how many distance is required? Minimum distance is required, or at least how many distance is required to detect the error? It is k plus 1. Just simple. Okay. Okay. ये सोता रहता है ये लोग.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Now, for error detection, the last point see, for error detection, we are using that.
कोड दोनों सेम हो जाए. कोड वन दोनों कोड सेम हो जाए. कोड वन और सेकंड दोनों सेम हो जाए.
क्या बोल रहे हैं? मुझे समझ में नहीं आया. क्या बोल रहे हैं?
सर जो ये कोडवर्ड हैं दोनों, कोडवर्ड वन एंड सेकंड सेम हो जाए तो ये वैलिड कोडवर्ड होगा या इनवैलिड कोडवर्ड?
कोडवर्ड कभी सेम नहीं होता है. अगर सेम होगा then why we are construct the CW2. CW1 and CW2 must be, but when they are distinct. Sorry, they are not a distinct, sorry, they are unique. If CW1, that means what? Detecting means what? आप खुद सोचिए, CW1 में मैं 0000 start to bit 00 रख दिया. तो ये generally ये क्या होना? What is this? This one is called error detecting and correcting. That means what? There must be at least one bit is error. तभी तो detect हो पाएगा, तभी तो error हो पाएगा. The status of 0 है, when 0 is converted to the 1, that means obviously code 1 and code 2 is not similar.
यस सर. जैसे सर ये हो सकता है जैसे एक डिवाइस से हमने जैसे ये कोड सेंड किया और वो अगर यानी सेम आउटपुट जैसे दूसरे डिवाइस में जैसे एक्सेल यानी चला जाता है तो उसमें कोई एरर नहीं आता.
हाँ, तब तो एरर नहीं है. अगर सेम
तो सर उसमें एरर नहीं आएगा तो वो तो यानी एरर यानी वैलिड कोडवर्ड ही होगा फिर तो.
हाँ, वो वैलिड कोडवर्ड होगा. हाँ.
ओके सर.
This particular concept we are using when the errors are occur. ठीक है. जब अगर when sender sending particular one information to the receiver, if there are no changes the information, that means what? It is the valid. That means receiver successfully get the original information. Yes or no? That
yes,
particular information by default we are considering as a valid code word. Code word means what? Nothing but a binary sequence. And when this particular extra bit we are using, that is called a error detecting code or correcting code. To मैं पहले ही बोला आप लोगों को, to detect the error, that means original message में कुछ changes हो रहा है क्या, उसके लिए हम लोगों ने क्या use किया है? We can use some particular extra bit, and that is called a error detecting or correcting code. Okay, sir.
Okay.
For error detection and correction code, whatever we are using the some particular code, it is very popular and that one is called a priority code. Okay, now what is priority code? Now what happened? The slide name is what? Priority code for error detection. We are not discussing about the, just we are know what is the error correction, but how priority code generally used for error detection. Okay. The simplest technique for detecting the errors is that any extra bit, adding an extra bit. Some extra bit we are using to known as the priority bit. Okay, to each word being transmitted. When some particular code word is transmitted, some particular extra bit we are using, that particular extra bit is called a priority bit. But remember, for error detecting and correcting code, there are many methods we are using. Lot of methods are there, but this one is the one of the method. It is not like that only this particular method we are correcting and detecting. Okay, but it is based on different application, based on different concept. But what happened? For the electronic circuit point of view, generally people are priority code is a good example. Okay, for detecting the errors and correcting the errors. Okay, so there are two types of priority. One is called a odd priority and one is called an even priority. There are what? The priority codes we are distinguished by, or we are classified by two groups. One is called a odd parity, one is called a even parity. Now, what is odd parity? You just read this particular statement. The parity bit is set to a 0 or 1. It is does not border for us. It is 0 or 1. But how we can add the 0 and 1? At the transmitter, set to 0 and 1 at the transmitter such that the total number of 1 bits, I am talking about the total number, this one, total number of 1 bits in the word. Word means what? Nothing but a code word. Including the parity bit, parity bit is not separated. We are including the parity bit is generated the odd number. If message bit or information bit include with the parity bit and number of ones is occurred as an odd number, that time what happen? It is called a odd parity. Just opposite for even parity. The parity is set to a 0 or a 1 at the transmitter such that total number of 1 bits in the word, including the parity bit, is an even number. That time what happen? It is called a even parity. If it is odd number, that time what happen? It is called a odd parity. Okay? Okay? So you know what is parity bit and how many parity bits are there. There are two types of parity bits. One is called a odd parity, one is called a even parity. What is a even parity? You know, that means when the number of ones are occurred as an even number when we are combining the information bit with the parity bit. And number of ones is occurred as an odd number when we are including the message bit with the parity bit. That time what happen? That particular code word is called a odd parity. Now see, whatever we are discussing, this particular two definition, the last two, this one and this one. How we are defining the odd parity and how we are defining the even parity. Okay, and this is, suppose we are considering that this one is the BCD. You can increase this particular decimal number also. You can go to the 5 bits, 6 bits. Okay, you can increase, but we are supposed what happen? For example purpose, I am considering BCD code. Suppose BCD code, you know what is the weight? Weight is 8421. 2 to the power 0, 2 to the power 1, 2 to the power 3, and 2 to the power 4 from LSB to the MSB. Okay. And 0, 0, we are representing in BCD this way, 1 is representing this way, 2 is representing this way. See here, when the odd parity is generated, the number of 1 is what? Odd parity means what? Number of 1 is odd. Okay. So see here, here it is how many number of ones? No, all are 0. So this one is 1. Here, this one is already 1. How many ones are present? Only 1, this one. Okay, so it is already created the odd parity. So no need to add here 1 because this one is the parity. If we are adding 1, that time what happen? This particular message bit, this one is called a message bit and this one is called a parity bit, suppose. So if instead of 0, if I am writing 1 here, suppose I am writing 1 here, that time what happen? 1 and this one, how many numbers are generated? 2. And 2 is even parity. So here what happened? But we are considering the odd parity. So we cannot use 1 here. So this one is 0 because already 1 is occurred odd number. Here also, how many numbers of 1? Only 1 is there. So what happened? 1 is already odd. So here we are using 0. Here how many ones are there? Even. This one is even. Even number of ones are occurred. So what happened? We can convert to the odd parity because we are talking about the odd parity. So 2 plus 1, only 1 bit is required, 1. So what happens? It is constructed as an odd parity. So this 2 and this 1, 2 plus 1 is 3. 3 is odd number. So it is called a, so here we are including 1. So similarly, what happens? Only 1 is occurred. So 1 is already odd parity. So here it is 0. So, but here it is only 2 are there. This one is only occurred and this one is already created even parity. But we are considering only odd parity. So what happened? 1 is required. So 2 plus 1 is again 3. So similarly, we are going this way up to this one. See here already even. So we can convert to the odd parity. So here we are using 1. Just opposite in even parity. See, we are talking about the even parity now. So what happened? 0, 0. Already no ones are there. So already this one is 0. Now what happened? This one is odd, but we are considering the even parity. So here it is only 1 is occurred. 1 is odd parity, but we are converting to the even. So what happened? We are adding 1 here. Here it is 1. Also we are adding 1 here to convert to the even number. Here already 2. So 2 is already even. So here we are using only 0. So here it is 1. So 1 means what? It is odd. So here we are adding 1. So this way we are continue this one. This one is C here. Here 1, 1. This one is 1 and this one is 1. It is already even. So here we are writing 0. Any doubt this one?
No, sir.
Okay, you are getting. And this one is called a parity code for error detection. And this type of, when this type of parity we are setting, that time whatever it is called a odd parity. And when we are generating this type of parity bits, that time whatever it is called a even parity based on any particular binary sequence. Okay. And whatever, remember this one is called a sometimes this one is called a data bit. This one is called a sometimes some particular books it is called a data bit. Some particular books this particular part is called a message bit. Some particular book this particular part is called a information bit. But whatever, don't confuse data bit, information bit, message bit, all are same. And when we are including extra bit, this one is the extra bit. This particular odd parity and even parity is called a parity bit. Okay, if it is occurred this way, that time what happened? This is called a odd parity and this is called a even parity. And we are adding this particular extra parity with this particular data bit or information bit. Okay. Now what happened? We are talking about the error detection. Now what is error correction code? Okay, till now we are discussing error detection. Okay. So error detection and error correction, both the same concept we are using. Same concept means what? The definition is something different, but concept means based on parity code, we are same parity code we are using for error detection also, correction also, because detection is nothing but a first step of error correction. Okay. So now what is error correction code? A code is said to be a error correcting code. Error correcting code. This particular part is important. Error correcting code. If the correct code word can always be deduced from an erroneous word. Obviously, this is the general term. Suppose if something is wrong, and if you are identifying that particular wrong position, and you can correctly replace such that that particular position is correct instead of wrong. Okay. So same meaning. This one is what? If the correct code word can always be deduced from an erroneous word. Okay, so generally what happened? Generally there are many techniques are there. Okay, many applications are cryptography. You heard about the cryptography, and suppose when cryptography concept we are using when the data are transmitted, or suppose some particular image or some particular image type of security or some different type of securities are there. But Hamming code is one type of technique out of this one, so that it is also correcting the error code. So what happened in this particular subject we are considering only, because other particular subject you have know the other concept. So we are not going to discuss all other concept, but Hamming code especially related with this particular topic. So we are considering only Hamming code. Okay, one type of error correcting code is called a Hamming code. And this particular point already I am discussing why this 2k plus 1. When we are correcting the error, always distance must be required 2k plus 1 when k errors are there. Sorry, k corrections are required. When k corrections are required, that time whatever, how many distance are required? 2k plus 1. Okay. Now, what is the basic principle? When we are using the Hamming code technique for correcting or detecting and correcting the code, that time whatever, one particular code word we are using, that is called some particular technique. Now one particular technique we are using, that is called a Hamming code. Okay, and when we are constructing the Hamming code, that time whatever, we have to follow some particular principle or rules. Okay, the first rule is that to each group of information bits. Here k parity bits are added to form a m plus kb forward. It is very simple. Suppose what happens, suppose this one is the information bit or message bit or data bit. That time what happens, we can add some particular parity bit, and suppose this is the k parity bit. And this is the m. M means what? Suppose information bit, data bit or message bit. So what happens, for this one to this one, for this one to this one, it is called m plus k. Okay, so it is called a m plus bit code word. The value of k means what? K means nothing but a parity bit. The value of k shows to satisfy the equation, and when we are, how many k parity bits are generated, that time what happens, we are using this particular inequality equation or inequality condition. So what happens, suppose you are getting some particular information bit, and how you can decide that how many parity bits are required, 1, 2, 3, 4, how you can decide? For deciding the k parity bit, we can satisfy this particular rules or this particular constraint. 2 to the power k means 2 to the power k greater than equal m. M means nothing but a message bit, data bit or information bit, and plus k. K is nothing but a parity bit plus 1. So this way we can finding the how many parity bits actually we are using. Okay. So this particular part we are discussing with the help of some example. You wait for a few seconds, okay, or a few minutes. Now what happens? The next point, the parity seg bits are assigned position number that are power of 2. That means how we are assigning the parity bits? Parity bits we are assigning in this particular position. 2 to the power 0 means what? It is 1, 2. 2 to the power square means what? 4. 2 to the power 3 means what? It is 8. 2 to the power 4 means what? 16. This particular position, the parity bits are assigned. We cannot assign the unknown bit position. So always remember, when we are assigning the parity bits, that time what happens, always we can maintain this particular position. 2 to the power 0, 2 to the power 1, 2 to the power square, 2 to the power cube, or 2 to the power 4, 2 to the power 5, like that. Okay. The parity seg bits are computed based on some well-defined formula. That particular formula we will, very soon we will see what is the formula. Okay. How we can compute the parity bit or parity seg. Okay. The word format would as the we are writing from LSB to MSB. See here, if this one is the 2 to the power 0, so we are writing P1. This one is 2 to the power 1, so we are writing P2. So P1, P2 means what? Parity bit. And this one is 2 to the power 3 means what? 2 to the power 3 means 8. So we cannot put here. We can put here because see here 2 to the power 3, like that. So P4, P2, P1 all are the parity bit. And D3, D5, D6, D7, this one, this one, this one, and this one, all are called a data bit or message bit or information bit. Okay. Any doubt this one? भाई मत सोते रहिए. Any doubt? सो गए क्या? Are you there? Someone is there? Someone is there?
Yes, sir. Yes, sir.
मैं सोच रहा हूँ कि मैं
Yes,
ही
sir. Yes, sir.
मैं ही
Yes,
बोल
sir.
रहा हूँ, आप लोग बढ़िया से वो ऑन करके बिस्तर में सो गए हैं. हाँ, वेदर भी ठंडा है, सोने का मन कर रहा है क्या? सोइए, उससे मेरा कोई मतलब नहीं है. मुझे आप लोग से आउटपुट चाहिए बस. ठीक है? तो आउटपुट कैसे पता चलेगा? जब आप लोग को सॉरी माई नहीं करके ऑनेस्टली you can honestly you will complete your work. Okay, so that time what happen, your concept, yeah, उसके लिए क्या करना पड़ेगा? You can regularly study, you can clear your all doubts and concept. Okay. So this way. Okay, this is the slide number 6. If you are getting this particular all the points, then I'm moving to the next slide. Suppose whatever we are discussing till now, we are considering one particular example. Suppose we are using the Hamming code. We are talking about the Hamming code. Suppose we are considering the 7-bit Hamming code. Okay. Acha. Just you can write write all the points. आप लोगों ने notes में ये write किया मतलब इसको record करके रखा है ना notes में.
Yes, sir.
Yes, sir.
जैसे मैं पढ़ा के जाऊंगा लेकिन ऐसा मैं if you are thinking like that, sir, extra separately sending some particular special material for you, then your fault. This one is whatever I'm telling you. That means it's just my slide, and you can study your own textbook. I'm not giving sometimes some particular special chapter, suppose logic families, and sometimes some particular parts notes is required. That time I'm giving the slides to tell definition, and after that from the slides you can write down. That's all. Okay, because it is not an art subject, it is not a history subject, this is not an economic subject. I am providing notes. This is the technical subject, technology subject. Okay, you know the concept, you can study your own textbook, then you can automatically understand. Okay, you are the engineering student. Okay, so don't expect me. Okay, sometimes I will provide some particular notes or material that is something different, but it is not a so. But when I am discussing these particular points, then always write down all the points. Okay, and when you are why these particular points are important to you, because books are means what when you are studying from the textbook, that time these particular points helps you to understand. Okay, sometimes you can just you can read one by one line, another line, but you are not getting that time this particular ये थोड़ा देखिए just see carefully, and after 2 minutes just you tell me what I am doing. Okay, after देखिए, and if you are not getting, then obviously I will discuss this. Okay, after one minute or 2 minutes you can just tell me this one, what is this. Yes. Okay, see here, anything you are getting or not? Are you there?
No, sir.
Yes, sir.
Yes, sir. Okay. So this particular
Yes,
example you are getting, this particular whatever I am doing, you are getting or not? You are not getting, na?
No, sir.
Getting or not getting?
No, sir.
Okay, no problem. Just carefully check. Okay. This one is called a 7-bit Hamming code. Why the 7-bit Hamming code? That means what? M plus K. When we are finding the M plus K, that time what happened? M plus K, the equal is 7. So how many total number of bits are there? 7. It is extended any numbers, 8, 5 or whatever. Okay, so the 7 bit is generated, so we are applying 7 bit in the Hamming code. So this one is called a no, it is known as a 7 bit Hamming code. Now see here, this is the digit. This consider this particular table carefully. These all are digit. Suppose we are, you can extend any numbers, but for the time being, just I am considering only 0 to 9. Okay, suppose I'm just, this particular example, I'm showing only 0 to 9. Okay, and based on suppose 8 bit, 12 bit, whatever, you can design, you can increase this particular digits. See here how many bits actually we are using, except the decimal digit. How many bits actually we are using? 1, 2, 1, 2, 3, 4, 5, 6, 7. So it is 7 bit. Okay. See here P1, P2, and P4 all are parity. But P1, P2, P4 all are parity. And D3, D5, D6, and D7 all are the message bit. So in this particular sequence, that means I'm talking about this particular sequence, why I'm using only 3 parity bits, P1, P2, and P4. See here, in this particular one, so what happened? If k equal to 3, that time what happened? 2 to the power 3 means what?
8.
2 to the power 3 means what?
8.
8. And suppose what happened here, I'm using k value already we know 3. So how many, what is the value we can insert for m, we can satisfy this particular one,
4.
greater than equal. So obviously 5, if we are using 5 plus 3 and plus 1, this one is already plus 1, that time what happened? 5 plus 3 plus 1 means how much?
9.
9.
9. And the k value is what? 3. So 2 to the power 3 means what? 2 to the power 3 means what? 8. So 8 greater than equal to 9?
No.
No, this particular condition is not satisfied. So what happened? We cannot use 5 here. We are using 4.
4.
Are you getting my point? So 4 plus
Yes,
3, 4 plus 3 is 7, 7 plus 1 is 8. And 2 to the power k means what? K value is 3. So 2 to the power 3 means 8, and 8 greater than equal to 8. Whatever that means 8, we are getting 4 plus 3 plus 1. So what happened here? How many parity bits we are using? We are using k equal to 3 numbers of parity bit we are using. And if we are using 3 number of parity bits, and how many message bits are there? M equal to 4. M equal to 4. Okay. So when we are using 7-bit Hamming code, for this particular reason, we are using only 3, k parity bit is 3, number of parity bits are how much? P1, P2, and P4, and M equal to what? 4. D3, D5, D6, and D7. And D3, D5, D6, and D7 also call a message bit, data bit, or you can say information bit. Okay. Now what happened? You forget about, for the time being, just you forget about how we are getting the P1. What is the value of P1? You just forget. And how we are getting the P2 value and P4 value. Just you forget. Okay. Just we can put the data bit at first. So 0 means what? So 0 means this one is 0, this one is 0, this one is 0, and this one is 0. We are going from this side. From suppose we are writing this way, any binary sequence we are writing 0, 1, 1, something like that. So we are starting from left to right. Next one is what? 1. So what happened here? We are writing 0, 0, 0, and 1. Don't consider a parity bit. Okay. So I'm writing, I'm using different color for priority bit. So 2, just you consider the data bit. This one is 0, this one is 0, this one is 1, and this one is 0, like that. When we are considering the 9, so just you consider the data bits 1, 0, 0, and 1. 1, 0, 0 means what? 9. When we are considering the 8, 1, 0, 0, and 0. This way we are constructing the data bits or message bit. Okay. Now what happened? How you are assigning the, how we are getting this particular value P1, P2, and P4. For that particular purpose, here I am mentioning that the parity checks, this one, the parity check bits are computed based on some well-defined formula. So what is well-defined formula? So this one is described here. So see here in this particular next table, this particular table, we are writing here P4. P4, how it is generating P4 means 2 to the power square means what? 2 to the power square means 4. 2 to the power 1 means what? 2. So here I am writing P4, P2, and P1. 2 to the power 0 means what? 1. So here I am writing P1. Okay. So this way we are writing, just you can, the higher priority bit you can write at the top. Second higher priority bit you can write second top, and the last one you can write in the bottom. Okay. But when we are counting, see here, how many data bits are there? 1 to 7. How many data bits are there? Because this one is the 7-bit Hamming code. So we are writing decimal digit 1, 2, 3, 4, 5, 6, 7. So how we are representing 1 in binary sequence? We are writing, you can consider this way, top to bottom. 0, 0, 1 means what? It is representing 0, 0, 1. It is representing as a 1. What happened? It is representing decimal digit 1. So this one is 1. Next one is what? 2, 0, 1, 0. Third one is what? 0, 1, 1. Fourth means what? 1, 0, 0. 1, 0, 0 means what? 1, 0, 0 equal to 4. Next one is 1, 0, 1 equal to 5. Next one is 1, 1, 0 equal to 6. And 7 means what? What is the binary sequence of 7? Decimal digit 7, 1. This one is 1, 1, and 1. Okay, this way we can construct this particular table. Why we are using this particular table, I will tell you, because what happened, based on this particular table, we can compute what is the value of P1, P2, and P4. Now see, when we are considering P1, then you consider check all the columns of P1, where 1 is actually located, and when 1 is active. So what happens, see here, 1 is active, here I am writing in group. Okay, within, don't, for the time being, don't consider D3 XOR, no, sorry, D3 modulo 2, D5, D7, just for the time being, just don't consider this one. Just you consider this one. So P1 is active in decimal digit 1, so here I am writing 1. After that 3, P1 is 3, 1 is active, this one is active. Okay, so here I am writing here 3. After that 5, 1 is active, this one is active. Okay, so 1 means what? It is 5. So this one is 5, this one is 5. And another one is what? 7, this one is 7. So when we are writing P1, P1 make the group 1, 3, 5, 7. So similarly, what happened for P2? P2, 2 is active, this one. 3 is active, this one. 6 is active, this one. And 7 is active, this one. So here I am writing 2, 3, 6, 7. Next one, P4. Here all the ones are active, that means 4, 5, 6, 7. So I am writing here 4, 5, 6, 7. यहाँ तक समझ में आ गया सभी लोग?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
After that, see here. Yes. Yes. Any doubt? Yes. Any doubt? Okay.
Sir, can you explain it again, sir? I missed it.
Which one?
Sir, P1.
Okay, this one, P1.
Yes,
So, are you getting this particular table?
Yes, sir.
How we can construct? So, see here, when we are considering P1, which particular columns are 1. Just we can numbering that particular column. So what happens, see here number 1, so it is 1. So here I am writing 1. This one. Okay. Next, see where 1 is present in column number 3. So 3 means 3 is active. Next one is what? Next one is 5. 4 is 0. So 5. I am talking about this one. So what happened? So this one is 5. Next one, this one is what? 7. Because 6 is 0. So we cannot consider 7. That means 0 means what? That particular column is deactive. And 1 means what? Active. Okay. So 7 means that particular column 1 is active. So 7 is 1357. Are you getting my point? So we are getting P1 1357. Okay. So similarly, what happened? We are for P2, we are getting 2367 from this particular table. And P4 we are getting 4567. Okay.
Yes, sir. Thank you.
Okay. Now what happened? Next? What is this one? And based on this particular formula, we can put the value of P1 in this particular table. Okay. Okay. See here. So how we are getting? Where is my here? Okay. So how we are getting this one? P1 equal to D3 modulo 2. This is the symbol of modulo 2 because we cannot use XOR because till now we are not discussing about the logic gates. When we are discussing the logic gates, that time we can use this particular term in different way. But till now you are considering this one is the modulo 2. D3 modulo 2 D5, D5 modulo 2 D7. What is the how we are getting? Why we are getting D3, D5, and D7? Why we are not considering D4, D6, something like that? Why only 3, 5, 7? See here, 1 means what? Already it is P1. P1 means what? It is already 1. Are you getting my point? P1 position is already 1, and P1 itself we are computing. So what happened? This particular 1 we cannot use here. Only 3, 5, 7 is left. So what is the position of 3, 5? 3, 5 means 3 means what? This one is 3. This one is 5. Position is 5. And this one is position is 7. So what happens? 7 position means what is the content of 7 position? 7 position content is D7. What is the content of 5? 5 position. 5 position is D5. And what is the content of position number 3? So position number 3 is D3. So here we are using D3, D5, and D7. And why we are using this particular operation, just wait for a few seconds, I will telling you why we are using modulo. And similarly, we are using P2. P2 means what? 2 is already referred as a P2 already. So we are not using any P2 here. P2 because P2 itself, we are defining this one P2. Other term is 3, 6, 7. So this one is D3, D6, and D7. Similarly, we are computing P4. P4 is already defined P4 itself, so we are not considering 4, and remaining number is 5, 6, 7. And from the table you can see that 5 position is D5, 6 position is D6, and 7 position is D7. So here I am writing D5 modulo 2, D6 modulo 2, D7. Okay. Now what when based on this particular formula, based on this particular rule, we can find the P1. So at first what happened? Just a minute. See here, at first what happened? At first, how we are getting P1? What is the P1? P1 is see here. P1 means what? P1 means D3. What is the value of D3? D3 is 0. And after that, what happened? P1 next is modulo 2 D5. So D3 is 0, D3 is 0, D5 is 0, and D7 is 0. So 0 modulo 2, 0 modulo 2, value is 0. So here we are putting P1 equal to 0. Here. Are you getting?
Yes, sir.
Getting or not?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
You're getting na?
Yes,
Any
sir.
doubt? Till now, whatever we are discussing, you are getting or not?
Yes,
Yes,
sir.
sir.
Getting, sir.
So P1 value is 0. How we are getting 0? Because see here D3 is 0, this one is D3 is 0, D5 is 0, and DC7 is 0. So when we are using modulo 2 operation, that time what happened? We are getting 0. So here I am writing P1 equal to 0. Now next P1 equal to 1. Why P1 equal to 1? Because 0, D3 is 0, D5 is 0, and D7 is 1. So 0 plus 0 modulo to 0 modulo to 1 means what? It is 1. So here we are putting 1. So this way what happens? This way we are getting P1 value. Okay, you can consider any P1 value. Suppose I am considering this one. So where now what is the value of D3? D3 is 0, D5 is 1, and D7 is 1. 1 modulo 1 with 1, that time 0, and 0 modulo with 0, that means 0. So here we are getting 0. Okay, this way we can evaluate the P1 based on this particular formula. Okay, next what happened? P2, D3, D6, D7. You can consider any one P2. Suppose I am considering this one. What is the D3? D3 value is what? 0. D6 value is 1 and 0. So 0 modulo to 1 modulo to 0 means what? It is 1. So here we are getting P1 in P2 is 1. Same thing, if we are using 7, the digit number 7, that time what happened? How we can compute the P2? P2 is D3 is 0, this one is 0. Okay, D6 is 0, 1, and D7 is 1. Okay, 1 modulo 1 means 0, and 0 modulo 0 means 0. So here P2 equal to 0. Okay, and similarly we are using the P4. P4, D5, D6, D7. So what happened? D5, D6, D7, this one. So how we are getting 1? 0 modulo to 0 modulo to 1 means what? It is 1, 1. 0 modulo to 1 means 1 modulo to 0 means 1. Or you can consider 0, 0, 0 modulo to 0 means what? 0. So we are getting 0, 0, this one. 0 modulo 0, 0 modulo 1, so we are getting 1. So this way we can compute the P1, P2, and P4. Any doubt this one?
No, sir.
All of you getting or not? If any doubt, then please ask me. Don't keep silence. Any doubt?
No,
No,
sir.
sir.
No, sir.
So we are going to the
No, sir.
slide. So already how we are constructing the table we are getting. Based on this particular concept, how we can correct the error. See, sorry. One thing, particular thing. This one is the error correction code. See here how this particular parity bit actually work. Okay. See here how we can use the concept of even and odd parity in this particular table. See here carefully, you can check why P1 is 0. See here P1 is related to what? P1 is related to D3, D5, D7. So D3, D5, D7 is in this particular part. In this particular part, okay, why P1 is 0? See here D3 is 1, D5 is 0, and D7 is 1. So how many ones are occurred? Even number of ones are occurred. Are you getting my point? Even number of ones are occurred. So P1 is what? 0. Why P2 is 0? P2 means what? D3, D6, D7. What is the D3? D3 is 1. D6 is 0. And D7 is 1. How many ones are occurred?
2.
Even number of ones are occurred. So P2 also 0. But why P4 is 1? See here. Because D5, D6, D7, already it is 1. Already is 1. How many numbers of ones are occurred? Odd number of ones are occurred. So to make it even, so what happened? P4 is 1. So this way we can see here also what happened. Suppose I am considering why P1 is 1. You can go to the concept of even and odd parity. So P1 is related to D3, D5, D7. So D3 means what? It is 0. D5 is 0, D7 is 0, 1. So only odd number of ones are occurred to make it even. So here it is P1, P1 equal to 1. Are you getting my point? Why P2 equal to 0? P2 equal to 0 means what? D3, D6, D7. So D3 is 0, D6 is 1, and D7 is 1. Already it is even, so it is 0. Why P4 is 0? P4 means what? D5, D6, D7. So many ones are occurred, even number of ones are occurred, so it is 0. So this way we can use the concept of even and odd pair. Any doubt this one?
No, sir.
Any doubt?
No, sir.
No, sir.
Now what happened? Based on this particular concept, how we can how can calculate the 3 seg bits? 3 seg, why I am using 3 seg bits? Because what happened, there are 3 parity bits. So if you are using 4 parity bits, that time 4 seg bits is required. Now in this particular 7-bit Hamming code, we are using only 3 parity bit. So what happened? 3 seg bits are there. So based on this particular what happened, based on this we can evaluate the seg bit. C1 means what? C1 means 1357. C1 means 1357. So here 1 means what? P1 parity bit, and other 3 bits are data bits. So here I am renaming as D3, D5, D7, and all we are using as a modulo 2 operation. Okay. So what happened? Next what happened? C2. C2 means 2367. This one is 2367. So P2 is bit position 2 is lying on P2. P2 means for parity bit, and other 367 is the data bit. C3 means what? C3 means 4567. So here I am writing P4, D5, D6, D7, where P4 is the parity bit. Suppose based on this particular pair, and when we are computing this one, always write MSB to the LSB. We are writing in this particular form: C3, C2, and C1. C1 is the LSB and C3 is the MSB. If C3, C2, C1 all are 0, 0, that time what happens? There is no error. If after computing C1, if you are getting 0, after computing we are getting the C2 value is 0, and after computing C3 the logic value is 0, that time what happens? If you are getting 0, 0, 0, that time what happens? There is no error. If other than, that means what? There is some particular error based on the bit position of the error is given by the C3, C1, C0. Based on this particular bit position, we can finding the location of that particular error and correct it. Okay, correct means what? If you are finding the location, if it is 0, then it is convert to the 1, because 0 is already error. So that particular position we know, that means if it is 1, then we are converting to 0, and 0, then we can convert it to the 1. Okay, suppose we are taking one example. Suppose code word, this one is what? Single bit code, because only one bit is set. See here. So this is the code word, this is the correct code word, and this is the error code word. Why we are considering the error code word? Because in this particular code position, 1 moves to the 0. Okay, now what happens if we are applying this particular concept and this particular concept? That time what happens? How we can minimize, how we can finding the error? C1 means what? P1. So P1, what? This one is P1. This one is what? P1. P1 means value is what? 1. So here I am writing 1. Next, D3. So 1, 2, 3. So 3 means what? This one is 0. 4, 5. If this one is 3, 4, 5. 5 is 1. This one is 1. And after that 7. So last bit is 7. 7 bit is 0. So here 0. So we are getting 1 modulo 2 0 modulo 2 1 modulo 2 0 means we are getting 0. C2 means what? C2 is P2. Where is the P2? Okay. Because we are considering only the code word. When we are finding the bit position, we are not using the valid code word. We are going to the error code word. We are considering this particular code word. Okay. We are considering only this particular code word. C2 means P2. P2 is this one. D3, 1, 2, 3. D3 is D1. D6, this one is D6. Which one? D6, D3, D4, D5, D6. This one is D6. D7, this one is D7. So last one is D7. So all are 0, and 0 modulo to 0 means what? This one is 0. This one we are getting 0. Okay. Next one is C3. C3 means what? P4. Which one is the P4? This one is P4. This one is 0. 5. This one is 1. This one is 1. 6. This one is also 6. And this one is 7. So 0 modulo to 1, 1, 1 modulo to 0, 1, and 1 modulo to 0 means 1. So we are getting this one is 1. Now what even we can read in this particular fashion. So C3 value is what? 1. Okay, this is the 1. And C2 value is what? C2 value is 0. So C2 value is 0. And C1 value is also 0. So 0, 0, when we are converting in the decimal form, that time what even it is 4. So 4 bit position is 4 bit position. See here, 4 bit position. We are 4 bit position. See here, 1, 2, 3, and 4. 4 bit position is same. Now it is 0. Now it is converting 0 to 1. So here I am writing therefore 100 is 4. Hence the 4th bit position is error, and it is corrected by the changing the logic value. Now it is what when 4th bit position is 0, and now we are converting to the 1. And when we are converting to the 1, we are getting our valid code word 10011100. Also, कुछ बोलिए response.
Yes, sir.
So can you explain the example again?
What is the valid code word? Valid code word is 1001100. What is the error code? Suppose we are assuming this one is the error code. 1000100. So see here it is 1 is same, 00 is same, 00. Third bit position of 00 is also same. But when we are going to the 4th bit position, see here the code word 1 convert to the 0. Okay, so it is this particular 4th bit position is something wrong. Suppose we are assuming, okay, we can cross check if we are applying our this particular error correction technique. That time what happened, we can get the final 4th bit position or not. Okay, and other remaining after 4th bit position, other remaining bit position are same. Suppose this one is the single bit error. Okay, now what happened, you can know how we can compute this one 1 modulo to 0 modulo to 1 modulo to 0 based on this particular formula. P1 modulo to D3 modulo to D5 modulo to D7. And so here I am writing 1 0 1 0 1 modulo to 0 0 modulo 1 1 modulo 0. And what we are getting, if we are applying this particular modulo operation, we are getting the 0. The logic value C1 value is 0. Now what happens C2? C2 we are applying P2 modulo to D3, D3 modulo to D6, D6 modulo to D7. So we are getting 0 0 0 0. So here what happens, we are getting the value of C2 value is 0. And C3 also we are getting P4. P4 means what? 1 2, we are going from the error code word. We are not going for the this particular correct code word. We are going for the error code word. Suppose what happens, C3 equal to P4, which is the 4th bit position. 4th bit position is in error corridor is 0. So here I am writing 0. After that 5, this one is for after 4, this one is the 5th bit position, and C3 is P4 modulo to D5. Due to D5, the 5th bit position, the value of 5th bit position is 1. So here it is 1. 6th bit position is 0. So it is 0 to 0. This one is 0 and this one is 0. And this particular 0 is coming because 7th bit position is 0 in the error corridor. So it is 0. Okay. So when we are applying the modulo operation, we are getting the 1 0 0. Now what happen? We cannot use 0 0 1 because what happen? Already we are saying that the format is something like that: C3, C2, C1. So what is the value of C3? C3 value is 1. So here I am writing here 1. C2 value is 0. So it is 0. And C1 value is 0, 0. And when we are converting this particular binary sequence to the decimal, we are getting the 4. The decimal value is 4. Now what happens? This particular 4 says that the error in error code 4th bit position is errors and you can correct it. So 1, 2, 3, 4. 4 is already, we know this particular bit position is already goes 1 to 0. Now what happens when we are getting the position, error position, that time what happens, whatever value 0, we just convert to the 1. So 0 we are converting to the 1. So we are originally, we can get this particular correct code. Are you getting?
Yes,
Yes,
sir.
yes,
Thank you.
understood.
Yes, sir.
Now see some particular example, encode the data bits. I'm already says that you see here the word format would be as D7, D6, D5, P4, D3, P2, P1. If you are considering from LSB to MSB, because this one is the less weight, 2 to the power 0, 2 to the power 1, 2 to the power cube, 2 to the power 0, 2 to the power 1, 2 to the power square, 2 to the power cube, 2 to the power 4, 2 to the power 5, 2 to the power 6, something like that. Okay. So what happens when this type of question is coming? Encode the data bit 0, 0011 into 7-bit even parity. So in this particular question, it is especially mentioned that you can use the concept of even parity Hamming code. Don't use the concept of odd parity. That time what happens? We can use this one. So what happens? We know what is the data bit pattern. You can just remember this particular bit position. Okay, we are talking about only 7-bit. So what happens here? Parity bit is 3 and data bit is 4. Okay, so we can, because why 3 and 4? Because I have already discussed based on this particular formula. 2 to the power k greater than equal to m plus k plus 1. So for that particular one, see here, we don't know what is the value of parity bit. Just we know the data bit. So data bits is already given 0011. Just you can put from MSB to LSB. D7 value is 0 because here it is 0. D6 value is 0, so here it is 0. D5 equal to 1, so 1, and D3 is 1. No other data bits are there. Okay, suppose this particular data bits already given. So how we can compute P4, P2, P1? See here, the first one, you know, when we are computing the P1, what is the group? The group is 1357. Plus you can put 1357. 1 is already P1. Okay, 2 to the power 0 means what? Already it is covered by P1. So we cannot write anything, just write P1. And 357, what is the value of D3? D3 is 1. So here I am writing 1. 5 is 1. So here I am writing 1. And 7 is 0. So here it is writing 1. So whatever it is already, how many numbers of ones are occurred based on the event parameter formula? And the concept of event parity, already 2 ones are occurred. So 2 is even. So P1 must be 0. So here I am 0. So if you are using P1 is 1, that time whatever, it is not an even parity, it is going to the odd parity because number of ones are, then that time number of 1 is 3. But here if you are using P1 equal to 0, that time whatever, we maintain the even numbers of 1s. So 1 1. So next one is, see here, P2, you know 2, 3, 6, 7. P2 is already covered in 2 and 3, 6, 7. 3. What is the value of D3? D3 is 1. D6 is 0 and D7 is 0. Okay, it is 1 0 0. So how many ones are occurred? It is odd number. Now we can construct to the even parity. Now we convert to the even parity. Okay. Now number of 1 is odd. So we can P2 must be a 1. When we can include P2, that time how many numbers of 1? 2 numbers of 1 and 2 is the even. So it is converted to the even parity. So here P2 must be a 1. And bit P4 4 5 6 7, because you know P4 is 4 5 6 7. So 4, 5, 6, 7 is what? P4 is captured by 4, and other 5, 6, 7 is 5 value is D5 is 1, 6 D6 is 0, and D7 is 0. So 1, 0, 0. And how this one is what? It is already odd parity. So we can use P4 must be a 1. So we can P4 value is 1 such that it is convert to the given parity. Now what happen? We can write D0. We can write this one is D0. D6 is D0. D5 is 1. Now what when P4? What is the value of P4? P4 is 1. So this one is P4. D3 is 1. So this one is 1. Okay, P2 value is what? 1. And P1 value is 0. So finally we are getting 0, 0, 1, 1, 1, 1, 0. Are you getting or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now just you write one particular assignment and tell me. Next class you can just complete this one, and you can tell me. Suppose here I'm using, what is the I'm using in this, you can write, suppose to 5, then how many parity bits are required? And for 5, how you can compute P1, P2 or P4 or many other P4s are required. That means many other, other than the some particular parity bits are generated. So how you can construct this particular table when data bits are data bits are 5 instead of 4. You can construct. Next class you can just show me the presentation. You can prepare one particular slide this way and you can keep with you. ओके मैं किसी का नाम बोलूंगा तो वो प्रेजेंटेशन करके वो स्लाइड मुझे दिखाना पड़ेगा. ठीक है, मैं क्या बोल रहा हूँ समझ में आ रहा है ना?
Yes, sir.
तो मैं इसमें क्या
Yes,
किया,
sir.
इसमें मैंने क्या किया, मैं डाटा बिट का वैल्यू 4 रखा. अभी आप लोगों को क्या करना है, डाटा बिट का वैल्यू 5 करना है.
5 रखना है.
टू दी पावर के ग्रेटर देन इक्वल टू m प्लस k प्लस 1. वो कितना पेयरिटी बिट आएगा वो कैलकुलेट कीजिएगा और इसके हिसाब से आप लोग का पेयरिटी बिट का वैल्यू, जितना भी पेयरिटी बिट जनरेट होगा उसका वैल्यू निकाल लीजिएगा. निकालने के पहले क्या करना पड़ेगा, आपको ये फॉर्मूला कंस्ट्रक्ट करना पड़ेगा. यू कैन कंस्ट्रक्ट दिस पर्टिकुलर फॉर्मूला और उसको एक दो स्लाइड में हो जाएगा, एक ही स्लाइड में हो जाएगा. ठीक है, सबके पास रखना पड़ेगा. मोबाइल यूज कर रहा है, लैपटॉप यूज कर रहा है, आई एम नॉट बोर्डरिंग अबाउट दैट वन. मैं किसी का नाम बोलूंगा, किसी का नाम से मैं उन लोगों को बुलाऊंगा. बुलाने के बाद वो प्रेजेंटेशन करना पड़ेगा. उसको प्रेजेंट ऑप्शन में आप क्लिक करके अपना स्लाइड मुझे शो कीजिए. ठीक है,
Okay, sir. Yes, sir.
जिसको सुनाई नहीं दे रहा है, जो भी अभी मेरा मीटिंग में नहीं है तो उन लोगों को इन्फॉर्म कर दीजिएगा. नहीं, जरूरत नहीं इन्फॉर्म करने का, क्योंकि वो लोगों ने मुझे, मेरा सामने वो लोग सोच रहे हैं कि मैं प्रेजेंट हूँ करके. ठीक है, मैं जानता हूँ बहुत सारा लड़का अभी भी प्रेजेंट नहीं है, बहुत सारा लड़का आज ज्वाइन भी नहीं किया. ठीक है, तो अगर उन लोगों को इंटरेस्ट होगा तो तुम लोग को पूछेगा तो तभी बोलना सर ने ये करने के लिए बोला है. ओके, जिसका अगर इंटरेस्ट नहीं है उसका जबरदस्ती फोर्सफुली हम लोग कुछ नहीं कर सकते. लेकिन मैं किसी का नाम दूंगा, अगर वो मुझे शो नहीं कर पाया तो उसको मार्क्स में इफेक्ट होगा, वो इंटरनल में भी इफेक्ट होगा. इंटरनल में वो मैं उसको उसका सिंसियरिटी के लिए मार्क्स रहेगा, उसमें उसका मार्क्स में काटूंगा. ठीक है,
Yes, sir.
नेक्स्ट क्लास स्टार्टेड फ्रॉम सैटरडे 10 to 11
10
or maybe मे बी 10 to 12।
सर लेकिन सर अगर हमने बना भी लिया, लेकिन सर मोबाइल में सर प्रेजेंट होता है क्या? मोबाइल में गूगल मीट यूज करने पर
टैब स्विच करने से हो जाएगा।
हो जाएगा। तो
टैब स्विच करने से हो जाता है।
अरे भैया तुम भैया इंजीनियरिंग का लड़का होगी क्या लगा, 3rd सेमेस्टर पर मोबाइल पे होगा। तुम्हारा मोबाइल में मेल कैसे मतलब देखते हो? जीमेल देखते हो ना मोबाइल पे?
हाँ सर
पहले
वो
ये
तो होता है।
जीमेल खोल पाते होता है नहीं, जरा
हाँ,
स्मार्टफोन जीमेल में
सर
जीमेल खोलते हो तो सब कुछ खुलेगा, ठीक है।
ओके
तुम्हारा
ओके सर।
भले ही उसके लिए अलग सा ऐप है मोबाइल के लिए, लेकिन वो अगर इफ यू आर मतलब मिनिमम क्राइटेरिया ऑफ स्मार्टफोन का फैसिलिटी अगर तुम्हारा स्पेसिफिकेशन में है तो हो जाएगा, ठीक है। वो कैसे होता है बाकी किसी को मत बनाना, वो उससे गूगल सर्च मार के देख लो कैसे क्या करना, ठीक है। ये हो गया। ये मैं अभी इसको क्लोज कर रहा हूँ, इसको मैं ओके जस्ट मिनट वेट फॉर फ्यू मिनट्स। क्या प्रॉब्लम हो गया ये? हाँ एक एक करके मीटिंग को लीव करो।
थैंक यू सर।
थैंक यू सर।